With me on the other end of our Skype connection is Dr. Tom Sharkey, who is with Michigan State University, and he is doing research into, of all subjects, rubber, and a particular interesting piece of the equation called, I believe, Tom, it's called bio-isopremes. Is that correct?
Yes, isoprene is the basic building block of rubber.
Okay, super. Now, the reason we're interested in this is because, as I was mentioning to you earlier, I've been reading Charles Mann's sequel to 1491, his new book, 1493, in which he talks a great deal about what happened after Columbus and the European, if you will, invasion of the New World, what that has done biologically. And one of those impacts is rubber. And so I thought it would be great to talk to you about your research, because you're looking for a way to essentially either supplement or eventually perhaps even replace our dependence, a significant dependence on latex, natural rubber. What I didn't realize, Tom, is that rubber, I thought, well, all tires are made synthetically now, and, why do we need latex and rubber trees? Well, it turns out you can't have a decent tire without latex. And so that had promulgated all kinds of plantations all around the tropical world. So you're interested in seeing if we can find a way to do that. So what got you interested in this in the first place?
Well, I've actually studied isoprene itself for many, many years, and I'm more interested in the fact that trees make tremendous amounts of isoprene. In fact, more hydrocarbon goes into the atmosphere as isoprene from trees than all of the unburned gasoline, all of the anthropogenic hydrocarbons going into the atmosphere.
Okay, so maybe explain for us, what is isoprene? Why is that important?
Isoprene is a 5-carbon molecule with a branched chain, and it's the thing that gives its name to this huge family of compounds that includes things like cholesterol, vitamin A, just many, many things are isoprenoids, and they're based on this 5-carbon building block. One of the things that's based on this 5-carbon building block is rubber. So you take about 10,000 of these isoprene molecules and hook them together. They hook together very nicely, and that's rubber. And so the isoprene itself, we thought was not very important in nature, but it turns out that plants make a tremendous amount of it. And that really is what I've been studying, and been studying for decades. And about 15 years ago, I cloned genes that allow us to do the final step to make isoprene. And it occurred to me that if we need isoprene to make rubber, and the synthetic rubber made from isoprene can be very high quality rubber, that maybe we could use this gene that I've cloned, put it in bacteria, and get the bacteria to make the isoprene, collect that, polymerize it into rubber, and reduce our reliance on the rubber trees. One of the issues with the rubber trees is that they come originally from, the best ones come from Brazil, Hevea brasilensis it's called, and seeds were taken from Brazil to Malaysia. Now most rubber production is in Malaysia. In Brazil, the trees get affected by a fungus.
Yes.
And wipes them out. So there's almost no rubber industry in Brazil. If that fungus gets established in Malaysia, we're going to have a very hard time getting enough rubber for our tires, for our cars.
Yeah,
and tire companies are worried.
Yeah, well, what interests me was, and Mann points out here, is that naturally occurring rubber in the Amazon region where it was growing, the trees were dispersed wide enough that the progression of this particular disease wasn't easily spread. Apparently, it could raindrops would knock it off the leaves and things like that, and it wouldn't spread quite as readily. But as soon as you start creating these vast plantations, such as what we now have stretching, through Indonesia, Malaysia, clear up into Vietnam and Laos and China, you've got the makings here of a very serious problem. And as I understand, at least what Mann is saying, there is no, if you will, antidote. There is no way to stop it.
Seems not to be, yes. Another book that covered this was a book called Fordlandia.
Oh, yes, right, yeah.
Yes. Very interesting reading about the failure of his attempts to reestablish rubber plantations in Brazil.
Right. Well, what was interesting, you're mentioning the seeds. Basically, they were pirated.
Yes.
They were pirated by some British buccaneers, if you will, out of Brazil, sent, if I recall the story, sent to Kew Gardens in London, where they were matured into seedlings, and then those seedlings were then shipped to, I believe, India. No, I think they went originally to Ceylon.
Yes.
And then from Ceylon, they ended up being, over into Malaysia and succeeded in being, grown there.
That's my understanding of the story too. Yeah. So they call it biopiracy.
Yeah. So we have the threat here. I mean, and how serious is this? I mean, if this thing, and given the fact that there's, the kind of globalism we have anymore, a tourist could, in fact, man even says that, he says, I was in the forest where this bacillus is located, this virus. He said, I could have picked that up, and, a few weeks later, I was traipsing through these plantations in Laos and China. I could have transported that virus. So, I mean, at some point, yes, there's that risk that this is going to happen. How long would this take before this really became a serious problem for the industry?
Oh, I think it could take as little as 2 or 3 years once it got a foothold. Once the disease gets a foothold in Southeast Asia, it'll march right through, I think, the whole area. And in 2 or 3 years, enough of the plantations would be damaged that rubber prices would just skyrocket.
Yeah, which of course is why you're interested in trying to find a way. So explain how would this process work? Would you say you do the bacteria, and this bacteria that you have essentially engineered would what then consume plant matter? How, sort of walk us through the process.
Yeah, it would consume plant matter. I mean, ideally we would get things that wouldn't be used for other purposes, but initially it would be like the sources of sugar that they use for making ethanol. But just that sugar source, we would mix that in with bacteria. And then what's different about the isoprene compared to other chemicals like this is that it comes out of the solution. It evaporates because it's got such a high vapor pressure. And then we just collect it out of the air phase over on top of the bacteria. And so we can just keep feeding them sugar and keep taking the isoprene off the top. We condense that and send that to the chemical company, and they would polymerize it and turn it into rubber.
Now, so I'm guessing that doing the rubber tree part is probably less energy intensive, other than the fact that you have to go off and collect it. And if I remember correctly, there's sort of like a fairly short window of a few months when that sap starts to rise or whatever, and the people actually go out and collect the rubber. That's a lot of manual labor, I'm guessing. I don't know enough about it.
It is a lot of manual labor. You have to physically go out there to each tree and take this little bit from each one until you have, a large amount of rubber, enough to make a tire. And so this would be very different. You would have the input of the sugar, and that's expensive. But then once you have it, one of the advantages is that it would be much more pure than the rubber that comes off the rubber tree. So one of the other things that we can do with this is we can make rubber gloves that don't cause allergic reactions. So right now, the gloves that the physician wears, they have to be made out of other chemicals. They can't be natural rubber, because natural rubber has proteins in it and other things that cause allergic reactions. So we can make more pure rubber. Oftentimes it has better properties. The very best rubber they have to use for jet tires. The tires on airplanes are really demand very high quality rubber. So some of the high-end tire companies are interested, and various people are teaming up with other biotech companies, and we're in a race. We're one of probably 3 major groups in a race. But my claim to fame is that I've cloned more isoprene synthases. So cloning is the way we get a hold of the gene. But I've done more than anyone else in the world, and I hope that I understand it better and can predict how to make it commercially viable.
Okay, so have you, in fact, at this point, actually made rubber? I guess would be the next question. So
I haven't made rubber. I've made a lot of isoprene in bacterial culture. So
okay.
I have bacteria that we've modified, and to get reasonable rates, we have to put in 4 different genes. But one of them is my isoprene synthase, and then we test that. And a couple of weeks ago, we were doing some tests, and the people in the lab came into my office and said, "Oh no, we have a problem. We've broken the machine," because the machine is designed to shut down if the signal gets too high. And so we had made so much isoprene, more than we predicted.
Right.
The signal went off scale and turned the machine off. And all we had to do was reset the machine. No damage was done. But it was one of those where this is a good problem to have when you exceed the capacity of the machine to measure it.
Right.